welcome to lecture number 41 of fuzzy sets, logic and systems and applications. In this lecture, we will discuss linguistic hedges. So, before we finally discuss linguistic hedges, let us go through the term linguistic variables. So, a linguistic variable is characterized by a quintuple, and this quintuple basically has 5 variables. And here these 5 variables are x, t x. So, x is generic variable and t x here is the term set, capital X is the universe of discourse, G here is the syntactic rule which generates the term set T x, and we have M which is nothing but the semantic rule which associates with each linguistic value. So, that is how we have these 5 variables, and these 5 variables are put together to be called as quintuple. So, if here let us say we take an example of a linguistic variable, let us say a linguistic variable here is age. So, if we have age as the linguistic variable, so let us see how these 5 variables look like. So, we see that if we have age, age. So, what is the generic variable in this case? So, here the linguistic variable or the generic variable, basically the linguistic variable is the age, but we have x as the generic variable, and then here we have the term set T x. So, for age we can have term set, and this term set can be a collection of multiple linguistic values. When we say linguistic values, it means the fuzzy sets. So, every linguistic value is represented by a particular fuzzy set, and here the term set T x, and since here age is a linguistic variable. So, our T of age, or I would say the term set for age can be here in this case young, middle aged, old. So, this is just for the example, and we can have multiple segregations, multiple fuzzy sets for age. So, term set can be basically a collection of the linguistic values for a particular linguistic variable. So, if we have a linguistic term like age is young, this will denote the assignment of the linguistic value young to the linguistic variable age. So, the linguistic variable, as I have mentioned here, if we have age as the linguistic variable. So, linguistic variable is normally represented in terms of the generic variable x. So, as I mentioned that this linguistic variable can be segregated, can be divided into multiple linguistic values. Here in this case, we have divided the whole region of age in 3. So, these 3 regions basically are young, middle aged, old, like that, but we can have multiple such regions which could be represented by the linguistic values, and these linguistic values are normally represented by fuzzy sets. So, here we have this fuzzy set, this linguistic value young, and this young is nothing but the lower side of the age representation. So, young is a fuzzy set here, is a left open fuzzy set, and we have this, the middle one is middle age, and here this middle age is represented by another fuzzy set. Similarly, we have the old age here, which is represented by a fuzzy set which is right open. So, as I mentioned that when we are dealing with the term set, we can suitably divide a particular linguistic variable into multiple fuzzy regions, and every fuzzy region is represented by a particular linguistic value which is represented by a fuzzy set. So, this way a linguistic variable is normally represented, and as in this case we have seen that age, if we have taken age as the linguistic variable, age has been divided into various fuzzy regions, and all these regions are nothing but is the collection of all these regions is a term set. So, here we have a generic variable x which is the measure of age. For example, we have 1 year, 2 years, 3 year, like that, and it can further go up to here in this case we are we have 90. So, these values are actually the values of the generic variable x, and x here is the age. Now, what is the universe of discourse? So, the universe of discourse can be all the possible limit of age, where the all possible values of the generic variable age, the linguistic variable age could be settled. So, within the total space basically is here termed as universe of discourse, capital X. So, in the term set T H, each term can be characterized by a fuzzy set of a universe of discourse. So, the capital X here is the universe of discourse, and this universe of discourse basically says that whatever value that small x can take or age can take will be belonging into the limit of the universe of discourse. Then comes the syntactic rule here. So, the syntactic rule is G, and it is symbolically defined by G. So, the syntactic rule refers to the way the linguistic values in the term set T are generated. So, in the figure that we have just discussed for age, where we have created multiple fuzzy regions for age, young, middle age, etc., are the syntactic levels. So, based on this syntactic rule, we create young, middle aged, old, etc. Similarly, semantic rule M. So, M basically helps us in specifying the procedure for computing the meaning of any linguistic value through specified membership function. So, we will have couple of examples, and with this we will be able to understand all these parameters. Now comes the composite linguistic term. So, here for linguistic variables we use word as values of linguistic variables in cases of linguistics we often use more than one word to describe a variable. So, for example, here the intensity of light, if we choose the intensity of light as a linguistic variable. So, let us now see how these 5 parameters, as we have seen those parameters which were as a quintuple, how actually are these coming up for this linguistic variable. So, intensity of the light basically here, if we are taking this as the linguistic variable. So, what is the generic variable, how we are going to measure the intensity of light, how we are going to represent the intensity of light, let us say it is x. So, x is the generic variable, and then what is the universe of discourse capital X. So, that the limit, the range within which we are supposed to take the generic variable values, and then the term set. So, the term set here for this case could be, if it is the intensity of light, it could be simply either low or high or medium or like that, or maybe dim, bright. So, these kinds of fuzzy regions or the linguistic values can be included in the term set, and similarly the syntactic and semantic rules could be created for these the linguistic variable, the intensity of light. Here we have written very bright, slightly dim, more or less bright. All these are little further if we discuss the hedges. So, these comes under that. So, we will understand these terms when we move little ahead. So, the linguistic variables we see here, the term set which we have for linguistic variables. So, this can further be generated, and let us now understand first that the linguistic variable may be a composite term and can be classified into 3 groups. So, as a whole, linguistic variable can have primary terms and then linguistic hedges, and then we have the negation and complement or and connectives. For example, if we take intensity of light, so what are the primary terms for the intensity of light? So, primary terms could be, for intensity of light, it could be, as I already mentioned, that could be low intensity, medium intensity, or maybe high intensity. Similarly, the linguistic hedges for the intensity of light could be, maybe if we add an adjective here. So, we could simply write very low intensity, or maybe more or less, medium, or whatever. So, similar linguistic values could be included. So, the linguistic hedges basically are with the adjectives in along with the primary terms, and then comes the negation class. Here we have the linguistic fuzzy regions where the primary terms are taken as either the complement or negation or with some other connectives like and or. So, for example, here we can write, we can use a term not low or maybe not medium. Similarly, we can have another fuzzy value which could be like this: low but not very low. So, here we see that but is the but is a connective. So, this way we see that we have some composite terms, and these are basically divided into three groups. First group is primary terms, second group is the linguistic hedges, and the third group is the complement and connectives. So, let us further understand this by taking some examples, and these primary terms and then the linguistic hedges, negation, complements and connectives can be understood further. So, if we talk of the primary terms, let us say the age which we have already taken in the beginning as the linguistic variable, then its primary term could be the young, as I had already mentioned, and in this primary terms the middle age can also be one of the linguistic value. Similarly, old. So, we have already seen that we have three fuzzy regions. This could be like this. So, we have, let us say, this is the universe of discourse here, and within this we have the generic variable x, which is nothing but the age, the measure of age, let us say years. So, let us say we have created three primary terms, and these three primary terms here are middle age or middle aged, and then we have the old, and here we have, let us say, young. So, these three are the primary terms which have been created here, and further these primary terms can be used with some adjectives or connectives to get the linguistic hedges. So, we will discuss this in the coming slides. So, here the primary terms basically are the fuzzy regions, primary fuzzy regions which are being created just to represent the basic building regions, basic regions. So, for example, here the age as the generic variable, age as the linguistic variable here is divided into three regions, three basic regions, and hence these young, middle aged, old are called as basically the primary terms. Now, these primary terms, as I have already mentioned, can be used as hedges by using the adjectives along with the primary terms. So, here as I mentioned linguistic hedges. So, in linguistic fundamental atomic terms, basically atomic terms are often modified with adjectives. So, here with adjectives and adverbs such as very, slight, more or less, fairly, slightly, almost, barely, mostly, roughly, approximately, etc. So, we see that everywhere we have some adjectives or adverbs, and when this is being used along with the primary terms or atomic terms, then this becomes linguistic hedges. So, let us understand this further with some mathematical expressions of linguistic hedges. So, if we have here a fuzzy set, let us say A, and if it is continuous fuzzy set, then we represent a fuzzy set, continuous fuzzy set like this. And similarly, we represent a discrete fuzzy set like this. So, the membership values which we use here for representing any fuzzy set, let us say A, whether it is a continuous fuzzy set or a discrete fuzzy set. So, if we have a membership function mu x which has been used in the basic fuzzy set in the primary term or the atomic term, that the symbol that has been used. So, if we have mu x, then how can we represent a linguistic hedge using the membership function of the primary term. So, here if we have the mu x which is here, the mu x is nothing but the membership function of primary fuzzy value. So, if we have mu x as the primary fuzzy value, when we say fuzzy set, primary fuzzy set, it means it is the primary term. Like in case of age, we have seen the young. So, young is represented by a primary set. This is a primary fuzzy set. This is also sometimes termed as a fuzzy value or the linguistic value, because all these, the linguistic value, fuzzy value, etc., are represented by a suitable fuzzy set. So, now let us make use of mu x which is used in the primary fuzzy set, and let us make linguistic hedge out of it. So, if we have mu x for a primary fuzzy set, then if we have to, let us say, use vary. For example, if we have, let us say, this mu x, I will write mu x here, and this mu x has been used for, let us say, young. This mu x has been used for young. It means we have a fuzzy region or fuzzy value which is represented by a fuzzy set A, and this A is nothing but this is for young. So, this mu x is for mu x here is a membership function, and this is for the primary fuzzy set, primary region, primary term. So, if let us say we would like to say it like this, we would like to modify the fuzzy set like this, like very young. So, how can we make use of this mu x and we convert it into very young? So, very young, we have used very before young, young we already know. So, how can we get a fuzzy set, let us say, which is A, and this is for very young? It is very easy, and we simply make use of the mu x that was given to us. We have to square the mu x. So, the mu x that was given to us, we will simply take it and then we will square it, and that is it. So, mu a can be converted into mu very a very easily by just taking square of the membership function. So, this way we are able to convert this into a linguistic hedge. Similarly, a membership value, if it is given, let us say, again this is the basic membership value mu a, and we are interested in more or less as the linguistic hedge, we have to simply dilate it. When we say dilate, means we are reducing the power. means we are taking the square root of it here. So, more or less can be represented by mu. The membership function for more or less can be simply the mu more or less of x is equal to mu a of x and then under root of it. Similarly, when we want to find the membership function of the extremely something, extremely, if we want to use the hedge is extremely, then this is equal to basically mu very 3 times, and then that is how it becomes mu a of x, and then we write here this raised to the power 8. This means we have applied very 3 times. If we take very one time, it squares the membership function, means we write mu a of x raised to the power 2. So, this way we are able to make use of the hedge, and we can apply the adjective over the primary term to make the linguistic hedge. So, with this I would like to stop here, and in the next lecture we will continue with some examples on linguistic hedges and negations, complements and connectives. Thank you.